Last video in this series, we're going to do another elastic collision with carts, okay? Now, in the old days, okay, before we had really good low friction carts and the carts were just not as well made, they would put these springs. So if you had the two carts crashing into each other, there was a spring that was made out of a loop of metal. Okay, so sort of imagine something like this. And so when the carts would crash into each other, they would go like this, out like that. It was kind of fun, you know. But the coefficient of restitution for those was not as good. Okay, excuse me. And so if you had two identical carts and you did the trick where one cart should stop and the other should keep going, you know, it wasn't perfect. With the magnets, it's a lot better. It's almost perfect. And there's still some friction that can throw you off occasionally. But so in this particular question, we're gonna look at a situation where we've got a collision between two carts, and there's a certain coefficient of restitution of 0.8. Okay, so this is not perfectly elastic. Okay, it's not perfectly elastic. It's just pretty good. It's just pretty good. Okay, so, oh, you know what? I need to tell you. Oh my goodness. I need to tell you about this. Okay, so let's talk about this before I forget. Okay, here's a ball. Right there, that's a ball. Okay. This is a mallet. And this over here is another mallet. Are you beginning to put this together? Can you tell what these guys were doing? This was a very short-lived sport called automobile polo. So you'd have one person driving the car, and then the other person had a mallet. So you've seen them play polo on horses, right? You know, so you're riding the horse and you got to hit the ball with your mallet. Boom, you know, kind of like that. So these guys were doing this with cars, and it was one of the early sporting events involving cars. Okay, so obviously they would race cars, and that stuck. People like that. This sport right here just turned out to be too dangerous, and so it didn't really catch on. But you see this kind of weird structure attached to the car, like so. Okay, and here's one over here too. That's a roll cage. Okay, so I mean, these people were doing this without seat belts, without airbags, nothing but nerve. But they did have those. So if your car, I shouldn't say if your car, but when your car rolled over, it was less likely to crush your head. But anyway, good times. So let's get back to this situation here. Okay. Alrighty. So let's set up our picture. We got our two carts, and I'll call them A and B again. So A is going this way, and B is actually going this way. Okay. So they're headed towards each other. All right. The velocity of A initially is 2. And the velocity, the speed of B initially is 2.5. There we go, just like that. Okay. Now on my drawing, I'm putting speeds. Okay. So notice I didn't put negative. Okay. I'll put negative 2.5 in later on, but in my picture, I've got the arrow. And so the arrow is all I need to tell me which way it's going. Remember, a vector quantity needs a magnitude and a direction. My arrow gives me my direction. I just have to write down the magnitude on that thing. Okay, so that helps me deal with that. Now we've got masses. Let's get our masses on there. MA. MA is 0.75. And MB is a little bit different, is it? Yeah, 1.5. 1.5. Boom. Okay, just so. So there's our initial picture. Okay. All right. Now for my final picture, what I'm going to do is, because this is the part where we don't know anything about what's happening. We don't know what VA is in the end. We don't know what VB is in the end. Okay, we're completely clueless. So what we do is we set it up like this. Here's A. VA final, we don't know that. We're just going to assume it goes this way. Okay, we're going to assume it's positive. If it turns out that it's actually going the other direction, okay, to the left, then we'll end up with a negative number. Okay, and then that tells us, oh, well, we guessed wrong in our drawing. Okay, and so and then we'll get to B, VB final, and again, we don't know what that is, but I'm going to call it this way. Okay, so that everything's positive. All right, on my drawing, everything's positive and to the right. So in the end, any number I get that's negative means it's going to the left. Okay, so I don't have to worry about, oh, which one's which way, whatever, because we really don't know at this point if A is going to actually keep going that way or bounce backwards. If B is going to keep going that way or bounce backwards, we just don't know. So now let's run the numbers. All right, so we begin with our momentum. Initial is final. Okay, it's going to get a little more complicated looking here, but it's the same thing. It's just we have a lot of information. So we've got MA, VA initial plus MB, VB initial, and that has to be equal to MA, VA final plus MB, VB final. Okay, just like that. Okay, so if we go ahead and kind of put in like the numbers that we know, okay, what we're going to end up with is 0.75. Okay, now I just don't have the room to write in all the units, so that's why I'm not going to write them in here this time. You can see my line's getting pretty big. I'm going to run out of, it's going to be hard not to run out of space. And I'm going forward at 2 meters per second. My next one was 1.5. Okay, here's where I'm going to put in the direction. Negative 2.5. Okay, so that's 0.75 VAF plus 1.5 VBF. Okay, now the left-hand side of that equation, if I run that on my calculator, I'm going to get minus 2.25. And that's equal to, again, 0.75 VAF plus 1.5 VBF. Okay. Okay, and you can see I have only the one equation, but I've got two unknowns, which means it's not enough. Okay, I'm going to have to get some more information. Okay, and we get that information from our coefficient of restitution relationship. Okay, so delta V final is minus the coefficient of restitution, delta V initial. So here we're going to have VA final minus VB final minus epsilon VA initial minus VB initial. Okay, and again, I know I've said this before, but just to reiterate, what you want to match is you want this and this to match and this to match. Okay, so keep track left, right. Okay, kind of which one is on the left, which one is on the right. As long as you're consistent, then everything will turn out just fine for you. Okay, so the final values, we don't know those. So I got VAF minus VBF Okay, so we got negative 0.8 onto 2 minus a minus 2.5. Okay. So again, I did my equations as if everything was positive, and I put that negative number in when I was ready for my numbers, okay, to make sure it goes that way. Okay. If you get ahead of yourself, and let's say up here, and I decided to put minus MBVB, then I would have to put this in here as a positive. Okay. And of course that would be negative. And that's just extra stuff to keep track of. Now, you could do it that way. There's no rule here, but just in my experience, you know, it's easier to be consistent instead of always monkeying around with your equations based on the direction. Okay. All right. So I'm going to get down here. VA final minus VB final is equal to, what is that? That's minus 3.6. Okay. So now I've got this situation again. I've got two equations here, just like this. Okay. And again, you should be able to solve this. Okay. So if you get something like this on a test, you should be able to handle this. All right. But you can use your calculator. That's okay. Anyway, when you do run the numbers, what you get in this case is VAF turns out to be negative 3.4. Okay, so that car bounces backwards. And the other one equals 0.2. So it bounces backwards also. It's just not going very fast. Okay, so these guys are coming in and they kind of go boink like this. Okay, although VAF is going to be cruising out of there. So I guess it's more like this. So they're going to come in here. It's going to be like, something like that. Anyway, okay, there we go. Now, we're going to bring up coefficient of restitution again. I want to, I hope to make a video for you about the very first lab that we did. You remember that very first lab? We were dropping balls and we were measuring coefficients of restitution. And I had it set up so you magically put everything in to Excel and then just poof, your answer appeared. Okay. And of course it made the histogram and all that, but we're almost ready to talk about how that works and how I did that and what that means for you. We're really close. Okay, we're really close. But this is all for now, okay? And so I've tried to do a wide variety of different scenarios for you to get you ready to do your homework, okay? There we go.